Okay. It's a bit weird, not quite sure what's going on, but nevertheless, let's go over some of these examples that we talked about yesterday. Hopefully this works out, but okay, let's call this number 1 here. We're going to look at sine theta equals negative 1/2 today. Okay, so sine theta is negative. Now remember, there's a couple of things we want to remember, right? Always remember what quadrant sine is negative. So all students take calculus. So what do we know about sine being negative? Where is sine negative? Remember, this here is quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. Now, sine is negative in what quadrants? What would you guys say? 3 and what? 4. Is that true? Yeah. So we're going to look for angles that are in quadrants 3 and quadrants 4, because this is where sine is negative. Okay, so we want to notate that negative sign. Now, we have to remember, though, that we always have to determine that reference angle. And the reference angle is a quadrant 1 angle. It's an angle that's actually positive. So we're going to look for where sine theta is positive 1/2 as opposed to negative 1/2, because we're looking for the reference angle. That reference angle is going to be the angle that goes here and here. This is always where our reference goes. Okay, do you guys remember this? So create yours, since sine applies to a right triangle. Okay, let's write a bigger triangle. Here's my theta. What's the definition of sine? Right, sine is going to be what? Opposite over hypotenuse. 1, 2. So what's the adjacent side if this is 1 and this is 2? Square root of 3. Good. So you guys remember, this creates a special triangle. Now, in my mind, this is 2, this is 1. Oh, I know what this reference angle is. What's the reference angle going to be? What is it? It's pi over 6, because it's going to be 30 degrees. Is that true? Good job. So that reference angle is what we're going to use here. This is pi over 6. And this is what? Pi over 6. Now these are not our angles. This isn't theta 1, this isn't theta 2. So let's say we call this angle theta 1 and this angle theta 2. Or let's do theta 1 this way. Let's do whatever, counterclockwise, I guess, right? So we're going to look for these angles here. Now, theta 1 is actually a quadrant 3 angle. So how do we find the angle theta using the reference, or I should say, if we know the reference angles in quadrant 3, how do we obtain the angle theta? Do you guys remember? That angle theta 1 will be, what? 180 degrees, pi, plus what? I'm going to put this in red. Plus my reference angle. Is that true? You guys okay with that? Okay, so then this theta 1 here, this first angle, since it's a quadrant 3 angle, is going to be 6 pi over 6 plus pi over 6, because we're adding a whole number with a fraction, if you want to think of it that way. We're getting 7 pi over what? Over 6. Here's my theta 1. So we're looking at this quadrant 3 angle here, theta 1. Let me highlight that angle. That's the angle we just found. All right, you guys okay with that one? Okay. Now I'm going to give you a little remark here, and I'll put this in red, that we're just going to look for the particular solutions, meaning this here is going to be between 0 and what? 2 pi. Those are our particular solutions. Now, the general solution, if we wanted the general, if you guys recall, all I'm going to do now is what with that theta 1? take 7 pi over 6 and add, remember, we need a coterminal angle to this quadrant 3 angle. The only way we get a coterminal angle is by adding and subtracting what? What did we do yesterday? Yep, the multiple of 2n pi. This gives me the general solution now. Okay, so we got a particular solution between 0 and 2 pi. If they want general, then we're going to write it in this way. And this now means if we wanted to look at the sequence formula, 7 pi over 6, right, plus 6 times 2n pi over 6, we get theta 1 to be 7 pi over 6 plus, looks like it's 12n pi over 6, or theta 1 will be 19, let's see, do we do, nope, can't do that, gotta wake up. You guys know, what is this? 7 pi plus 12n pi, everything over 6. So that your theta 1 angle will be, factor out, what do we get to factor out? Pi. This is pi over 6. And you get 7 plus 12n, where n is a natural number again. Remember that? Nope, sorry, n is an integer. So we have our first solution here in general. And then we have the second, or I should say it's the first solution. This is the sequence formula that we can use. We just actually have to just use integer values for n, and we could generate every solution a lot easier with this. Okay, so we talked about this yesterday. Anyway, this is just our first solution in quadrant 3. So we need the second solution, theta 2. Now theta 2 now is in what quadrant? Right, where's theta 2? It's in quadrant 4, is that right? So how do we find an angle? A quadrant 4 angle when the reference is actually pi over 6. We're going to take now what? 2 pi and subtract what? Pi over 6. Is that true? We're looking at this angle here. So we have to take 2 pi and subtract the reference, pi over 6. And that's going to give us, if we start doing the arithmetic, okay, remember you're going to multiply the top by 6 and the bottom by 6, and you should get theta 2 to be now, what is this, 12 pi over 6 minus pi over 6, and what do you get for theta 2? You get 11 pi over 6, good. So this is going to be my solution between 0 and 2 pi. Okay, so this is my particular solution over that interval. Okay, you guys okay with that one? So now if they want the general solution, right, what do you do for the general solution? This is going to be 11 pi over 6, and then plus what? Plus 2n pi. We're going to get every coterminal angle to this 11 pi over 6. So over here, we'll say this angle is 11 pi over 6. Let's change this. And we need every coterminal angle, just like for the first one, this is 7 pi over 6. Okay, so we need every coterminal angle. And we're going to do some algebra here. So we got 11 pi over 6 plus 6 times 2n pi over 6. So we'll get 11 pi over 6 plus 12n pi over 6. And here, this is good enough. If you gave me this on a test, I'll be good enough. But if you wanted a sequence formula, then, you know, factor out your pi over 6, and then you're left with what? 11 plus 12 n now. And that's for theta 2. And that will generate, you know, it's easier to use the natural numbers, or sorry, the integers, to generate your sequence of solutions. So we got the particular, here it is. We got the general, and we got the formula, the algebraic formula for generating a sequence. And we actually answered the question here, and this is 2 answers, particular here, general, and the sequence formula. And this is all satisfying this relationship that sine theta is actually negative 1/2. So I wanted to go with that kind of example. This is some of the stuff that we did yesterday. So does anybody have any questions on this that we did? Okay, I know this is, it's kind of repetitive, but it's necessary. You need to have all these details mastered. Okay, all these kind of definitions. And again, I titled this Trig Equations with no algebra, but it could have just been really in some sense titled Trig Equations by definition. This is your first place where you solve these here. Okay, everybody okay with this one? What do you guys think about this? Is that easy or is that hard? That's easy? Okay. Let's look at another question here. I'm going to call this 3, even though it's not, because I might actually do some other videos on that and have people work on even problems, So I'm going to call this like 3, example 3, or worksheet 3. How about if I say to you, if you guys remember, we're going to do something similar. Now let's do this here. Let's call this theta. And now we're going to say cosine theta is maybe 1 over the square root of 2. Okay? And I know a lot of times you might see this as the square root of 2 over 2 because they just rationalize the denominator. Is that right? Well, I want to point out to you that here cosine is what? It's positive. So I always go to this scheme of, now maybe I can draw it a little better this time. Just take things slower. It's very difficult on this. Okay, all students take what? Calculus. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Now, what do we know about cosine in this example? Cosine's positive, is that right? So in what quadrants is cosine positive? 1 and 4. You guys okay with that? So the answer is going to be an angle that's both in 1 and 4. So I'll draw a line. That's my first solution. Here's my theta 2. I'm going to have to find those angles. But before I do that, I always need this angle, which is a reference angle, right? And this is the same reference angle. And we call that theta, with that line on top. So I need that reference angle. So I want to point that out to you guys. We need to find this reference. And you find the reference by looking at cosine being, again, what? Positive. But they gave us that question as cosine being positive. So this reference angle, and to remind you that the reference angle is the angle in quadrant 1 here. So I'm going to emphasize this idea. In quadrant 1, the reference angle is the angle. Or we say the angle is the reference angle. So you might see me do this instead and take away that, it's the same angle. Well, what do you know about cosine? What's the definition? Adjacent over hypotenuse. And that should be square root. Okay. So in other words, 1 square root of 2. If it's 1 square root of 2, you guys want to tell me what the opposite side is? That's 1. Good. So you guys know here that the reference angle, which is the quadrant 1 angle, or the angle, is what? What special triangle? There you go. So you guys are on your way here. So this is pi over 4. Let me erase this so it doesn't look as bad. So we got a pi. Let's put that in red, that this reference angle here is actually pi over 4. Okay. All right, so we're on our way. Let's actually look at the particular solutions. So what I'm going to do here is I'm going to look at these particular solutions. And I'll say these solutions are solutions that are in what interval? Theta is going to be between what? 0 and 2 pi. Is that true? So let's find this particular solution, the quadrant 1 solution. Well, that's actually just what? That's pi over 4. Similarly, what would theta 2 be? Anybody know? Where's the second angle in? What quadrant? Yeah, it'll be 2 pi minus what? Pi over 4, because this is in quadrant 4. So let's do the arithmetic. Multiply the top by 4 and the bottom by 4. And you get theta 2 to actually be 8 pi over 4 minus pi over 4. What's 8 pi? What's this going to be? 7 pi over 4. So this first angle here, let's go back. I'm going to erase this. This angle is pi over 4. This angle, theta 2 angle, is going to be, what do we find? 7 pi over 4. It's a quadrant 4 angle. So remember, we're always using this reference right here. And there's a different formula for every quadrant. Okay, there's a different approach for quadrant 1, 2, 3, and 4. So we have to remember those ideas. The second thing we have to remember is when they ask us for a general solution, right? These are particular in this interval here from 0 to 2 pi. But if they say, hey, what's the general? You know, and they may. Your general solution, you're going to take your particular solution. Theta 1, which is 7 pi over 4. And what are you guys going to add again? A multiple of 2n pi, where n is an integer. And the second general solution is going to be found by taking the second solution, 7 pi over 4, plus again that multiple of what? 2n pi, where n is an integer. And you are now what? Done. So let's box this here. I guess we can include all of it. Okay? So here's your approach here for maybe in some sense example 3 or question 3 in a potential worksheet in the future that I might make for other trig students. So this is number 3. Okay, you guys okay with this one? All right, let's give you another one here before we move on to some of these other examples. Let's call this 5 in case this is going to belong to a worksheet in the future. Let's see what we should do. How about we do something like this? Let's say, what do we start off with? Sine 1/2. How about if we start off with, all right, let's do something kind of simple. What if they give you sine theta as 1? Sine theta is 1 here. So if sine theta is 1, what I'm going to remind you guys of, there's different ways we could go about this. For me, I keep it a little simple. Maybe you guys know a little bit more here, meaning I think of the sine curve, okay? Now here's positive 1, and here's what? Negative 1. Here's my x-axis. Here's the y-axis. And I have these various values. Where on this curve is sine the value 1? Oops, let's go back. This is my theta axis. In other words, for what angle theta do I get sine being positive 1? Yes, you look right here. You see this right here? There's an angle here. Okay. What angle is associated with this point here? Right? You get this 1. So sine of pi over 2 gives you the value 1. Is that the only answer in the interval from 0 to what? 2 pi. Is that the only answer? Yes, it is. Say yes, because this is pi. Yes, this is 3 pi over 2, and this is 2 pi. So what I want to say to you guys is, here's my solution. Okay? that theta is actually pi over what? 2. And that's in the interval of what? 0 to 2 pi. So if I go now to my, even though we say all students take calculus, all students take calculus, we're really talking about here a 90-degree angle. Is that right? This is where I would say to you guys that, this angle here. So on the unit circle, you're on that particular terminal point, right? So on this terminal point, we say, this is where you're located. I bring this up because when we talk about the general solution now, if you want to look at this general solution, okay, what do you do with this particular angle? What are you going to add a multiple of? 2n pi again. And n is an integer. So let's just assume from now on, when I just put n, it's going to be an integer. But, this is the, general solution here. Okay, so if you guys notice that 90-degree angle, in order to obtain any other coterminal angle to it, you have to add a multiple of 2n pi, or subtract a multiple of 2n pi. And that's why we have n as an integer. So to get this 90-degree angle, anything else that's coterminal, and I can't show you on this very easily on this iPad, I can show it on the board easily by just moving my hand, one revolution is 2n pi in either direction. So that's why we have this multiple. It's going to be a factor with some of the questions later. But now let's move on to not just the general solution. What about the general solution, the sequence sort of formula? Right? You might see this in higher math courses. Higher math courses like calculus, sometimes they give the solution in terms of a sequence. And all they're doing is adding here a fraction with a whole number. So you're going to actually just put this 2 and this 2 down here to get the same denominator. And you'll end up now with pi over 2 plus 4n pi over 2. Okay? Getting down here, it's a little harder to write. Okay. Factor out a pi over 2, and you get 1 plus what? 4n. So here's my sequence formula to find all the other what? Solutions. Okay, you guys okay with that? This is how we go about it. Now, let's talk a little bit about this stuff since I have the sequence formula. You guys notice a couple of things. If n is 0, right, let's generate these solutions like we did. What does my sequence formula give me? Just pi over 2, right? Because you say, what did you just do? I let this value be 0. Now 4 times 0 is 0, and 0 plus 1 is 1. And 1 times anything is itself. So 1 times pi over 2 is going to give us pi over 2. All right. Let's look at the case when n is actually 1 now. Now we're going to change that value. So we're going to go over some of the details we did. This will be 1. And now theta is pi over 2, okay, 1 plus 4. Or theta will be, what is this? 5 pi over 2. So these are two solutions. This 5 pi over 2 is out of the interval from 0 to 2 pi. So we're looking at this domain being all real numbers, no restriction on it. And again, like we did yesterday, if n was actually 2, we say theta will be pi over 2, 1 plus, change this number now from 1 to what? To 2. So it's 1 plus, what's 4 times 2? Is that 8? So theta is going to be 9 pi over 2. So you guys notice that if you have to generate a sequence of solutions, it is always best to go to this what? The sequence version of the general solution. And sometimes in courses you have to do that. And being here -1, we say theta being pi over 2, and 1 now minus 4. Why is that minus 4 now? You guys see what I just did? We plugged in -1 for n. So when you plug in -1 for n, that's positive 4 times -1, that's a -4. So your answer here is going to be theta is now negative what? 3 pi over what? 2. Here's the third solution when n is -1. Okay, now let's try the same thing when n is what? -2. We're going to generate some solutions here to illustrate the sequence approach, I guess, right? We're going to plug in what here now? -2, is that right? Okay. So let's see what we get. What's positive 4 times -2? -8. So my theta here will be, okay, my angle is going to be now negative what? 7 pi over what? 2. And there you go. So here's how we can start to use the formula here, you know, where n is various integer values, okay? And we're generating these solutions. Now, all these angles are coterminal, okay? They're coterminal to this angle right here, right? 90 degrees. And they share the same what? You can say they share the same terminal point, and that's what that meant to be coterminal. So we're getting every coterminal solution. So it's going to depend on what they ask you. Now, I'm going to go back and say something here. Does everybody have this in their notes here? All right, let's put this back here so you guys know. Everybody have this here. Here's your particular solution. Here's a general solution, okay? Here's a general solution, the what? The sequence, if you will, form of the general solution, an algebraic formula. Gives you multiples of pi over 2. Because I'm going to do something here. I'm going to have you guys note something really important here. It's important. Go back to this curve here. Now I'm going to change it. And I'm going to tell you guys, what if I did this change? I'm going to change this to, bless you, -1. You guys with me on this? Let's change it to -1. And then I'm going to say to you, if you change it to -1, what changes? A lot of things what? In fact, everything changes, right? So let's change this here. Let's erase this. We're going to erase this, and I'm going to say now, can you guys tell me, let's erase this because this is no longer the what? This is no longer the value of theta that we're going to use. This is no longer a solution because we now have to find where this is actually what? -1 as opposed to what? +1. You okay with that? All right, what does that mean? We're trying to find where theta provides sine being -1. So here's -1. Oops. Okay. What angle gives you -1 there? What angle we associate with -1 for sine? Did you guys see it? You guys think what's the angle? What's theta? Good, 3 pi over 2. And you go through the same kind of idea. Here's your particular solution in the interval. What's the general solution? I won't give you every detail this time. We'll add 2 and what? Pi. There's your general solution. And I'm going to say to you guys, you should be able at this point to do what? To provide or do the algebra. Okay, be able to do what we just did in the last few days here. So here's how you get the, you know, this kind of answer, just so you guys know. All right, you guys okay with that? And I'm going to say to you, let's do another note. See if you're really awake, because this happens a lot too. What if they want to know where sine theta is actually 0? So let's now erase what we have worked on. We erase this, right? You guys want to tell me where is sine theta actually, right? For what angles theta is sine 0? The origin, pi, and what? 2 pi. Now, some books, you know, address this. They only give you, they say this is the interval here of your particular solution, okay? So I'll address that kind of thing. Now you might say, why? Well, I mean, it doesn't matter at all, but I would say to you guys, your solutions they're going to be what? 0, and what else? Pi, and maybe also what? 2 pi. You okay with that? So depending on the interval they give you, that's going to dictate the answer that you provide. Okay? This has maybe 3 or 2 solutions depending on the interval and the restriction. It is 0, it is pi, and it is 2 pi. Notice these are also the intercepts, right? The x-intercepts or the theta intercepts. These are the intercepts, and that's important to know. However, let's note, what if they said, what's the general solution? So let's change this here. You now want to write the general solution. How do you do that? We can very elegantly simply say theta is going to be what? N pi. Okay, theta is n pi. Now let's look at some important details because it's going to come up in our future as well. Let me erase everything here. Let's draw some pictures. How did I get this n pi? Does anybody know? Why do I write this as just n pi? Do you guys notice what's happening here? Right, this is, we should say, or we can say that the number 1 is here, the number 2 is here. We can say that was maybe 0 pi. You with me on that? So if you notice that you're getting like the counting numbers or the whole numbers, 0, 1, and 2, and 3, and 4, and even the negatives now. Remember, n is an integer. So we can just simply use this particular formula in this case, just n pi. But I want you to consider something that we're going to have to look at. Let's also note the following, that if I try to find the various angles here, right? I'm sorry, this is the x-axis. Bless you. Theta being what? 0 is right here. Tell me if you guys agree. Is this a 0-degree angle? Say yes. Okay. What about pi? What does pi look like? Is this theta being pi? Is that the angle pi there? Remember, we're going how? We're going this direction, counterclockwise. You guys know what I'm saying? So here's where theta is actually 0. Here's where theta is actually what? Pi. And then, what would it look like? Let's change the color. Let's change it to green. What if theta is 2 pi? We're back over here. Is that right? So I guess I'm going to go back over here. So it may just seem like I'm just overstating things. I want to just kind of remark that if we just look at natural numbers for n, theta being n pi, don't we get every coterminal solution? Every coterminal angle? Okay, so here's my general solution. It's also the sequence solution. What I mean by that, if you said, I see some books that put negative 2 pi, negative pi, 0, pi, 2 pi, forever, I'll say yes because they're just using n being an integer value, an integer multiple. So here's your general solution. I want to point out that very important detail. So just looking at the sine curve, if you guys want to know the truth, I can actually ask you in the future that question here and maybe this question here as well. Those are very, very actually standard questions. And the same thing for cosine. So for cosine, you'll do the same. Okay, so let's kind of look at an example there for cosine if you needed to. This is all good material to go over all the details. So number 7. And these are the little things you guys want to remember. So let's call this 7. Let's say they give us cosine of an angle now being what number? Let's say it's positive 1. Let's go look at the cosine curve. Isn't this 2 pi? And what is this? Pi, and this is what? Pi over 2. What is this? 3 pi over 2. Is that right? So where is cosine actually going to be 1 now? Tell me by looking at this curve, where is cosine 1? 0. Right here and right here. Is that right? So for what angles do we have cosine being 1? What would you say? Theta is 0. And theta is, what's the other angle? 2 pi. Is that true? Now, it depends on your restriction. Now, if the restriction is between 0 and 2 pi, well, you got the two angles. But what do you guys happen to notice about these particular two angles here? If I draw, let me try to draw this next to it. Let's draw our Cartesian coordinate, x-axis, y-axis. The 0 angle is right here, isn't it? Isn't that a 0 degrees? And then let's rotate how? Counterclockwise. What do you guys notice if I draw this second angle, 2 pi? They're coterminal. Good, coterminal. So a lot of books and a lot of times they may just restrict that and say, okay, what's your angle? And then you just say, oh, now I have a single answer. Theta is going to be simply just what? 0. Okay? This is our particular solution for cosine being 1. They just threw out the 2 pi. So you're going to look at the restriction. Now, this is the, what do we call this? What is this? This is the, what, particular solution? How do we get the general? What would your general solution look like? Well, what do you do now? How do I get all the coterminal angles? If I say theta here is what? Is 0. How do I get all other coterminal angles to the 0 degrees? Good. You're going to add a multiple of, let's put it in red, 2n pi. And yes, n is an integer, right? But we'll say now, if I add 0 to anything, that means theta is simply going to be what? 2n pi. Okay, you guys are good with that? You good with this idea here? Pretty good? These are common questions. Let me toss in this other angle here. Let's change the color and maybe we'll change it to what? Blue or something, right? What am I asking now? What's the trig equation now if I change this? Let's keep that in blue. I'm going to say to you, note that cosine theta would be what value now? -1? Good. What do you say for theta? Theta is what angle? Where is cosine equal to -1? When theta is? What angle? You guys can say it. Theta's pi? All right. Good job. Theta's pi now. So let's go back here and in blue, let's find that angle. Theta's pi would be where? Right here. Is that true? Is that right? Isn't that when theta's pi? Rotate counterclockwise. Okay, so if that's the case, we'll say, well, what about this general solution? How could you describe that general solution here? You're going to take theta to be what? Pi, and then do what? What are you going to add? How do I get coterminal angles? 2n pi. Good. So let's be careful here with the algebra, right? This, in some sense, this is your general solution. But if you want the sequence, do algebra. Factor out pi, and what do you guys end up with? 1 plus 2n. Other books will write it simply as 2n plus 1 times pi. Right? They just switch that. And so, you know, you can see it this way, and that's where it comes from. But I want to point out, just by looking at the curve for some of those special angles, I mean, we can actually find what? These solutions as well. Now, let me paint this now green here. Or let's see, what should we try? Should we try pink? guys want pink? Yeah. You want green? Let's look at these solutions here. What am I asking now in green? Let's call that note. Let's note in green. That's ELAC green. What we're saying now is we're saying to you sine theta, oops, not sine, what was this, cosine? Cosine theta is what? What's cosine theta? 0? When does that happen? When is cosine 0? Theta is pi over 2 and what? 3 pi over 2. So theta will be pi over 2. Theta will be what? 3 pi over 2. Is that true? So there's two solutions in our interval from 0 to what? 2 pi. Two solutions. Now, let's say this. Let's consider the what? The general what? Solution. What would our general solution look like? Let's look at the general solution here. Let's go back over here, and I know, let me see, where is it at? Where did okay. I want to use this axis right here for you guys, okay? I'm going to erase this, I'm going to erase this. Now, I'm going to paint in green my solutions, the angles, right? Pi over 2 right here, and that's the first angle rotated counterclockwise, right? That's my pi over 2. And then, where's 3 pi over 2? That's over here. So I want to show you guys that here is a second solution. Theta is pi over 2, and then theta here is 3 pi over 2. This I want you guys to really consider, because notice what we did in the past. Every time we got a solution here, right? Let's say our solution here was, and it's pi over 2. What would I always add here in the past? I would always add 2n pi here. Now, that's not wrong. That isn't even wrong. I mean, let me explain this. It is certainly true that for this first angle, right, of 90 degrees or pi over 2, I can generate additional coterminal solutions by adding and subtracting multiples of 2n pi. Revolutions, complete revolutions. And then if I did that for the first one, I got to do it for the second one. So you might say, hey, we've been doing this way. We've been saying take now the second solution, 3 pi over 2, and then also here, also add a what? Multiple of what? 2n pi. So there's nothing wrong with us doing that. We can do this. However, there's a more efficient, here's an even better way. I'll put a star here. I'm going to say your general solution can be described as pi over 2. Now, I'm going to add not 2n pi, I'm going to add something that seems crazy. I'm going to add a multiple of just n pi. See what I just did here? Why does this make sense? Or why can I do this? Anybody want to tell me why? I can just simply add n pi. Huh? Look at these angles. Let's get another color. Let's look at these angles here. Okay? Once you get, let me color it this way. Once we got that theta being what? Pi over 2. Is that true? And let me erase this here, and let me erase this here. Isn't it true that all I'd have to do, I got this particular angle as a solution, if I rotate simply pi, don't I get that additional solution of 3 pi over 2? So that's pi. And what if I said to you, I rotate again another pi? Don't I get the coterminal to pi over 2? And can I do this all day long? So in other words, the second I notice that these angles are, what do we say? Supplemental, maybe, if we use language of geometry, the difference is 180, or if they're opposite each other this way, I could just simply add what? The multiple of n pi. That's what I'm saying. Do you guys understand what I just said? You guys see what's going on? I can generate every solution here. Let me put it here. I can generate this solution and this solution by first getting the pi over 2 and adding and subtracting n pi. And that's why if you look in back of the book, you don't see what we have here. They won't write this. You may see it, depends on the book. But typically, you'll see this representation, because they're being more efficient, that the angles oscillate between by a multiple of really 180 degrees n pi. They're actually supplemental to one another. That doesn't happen when you are looking at this situation. Let's go back to one of the others. And that's why I've been drawing this picture. That does not happen here. What I'm saying is, here's that first angle. You do not have an angle that's what? Supplemental on the other side. So that's why you can't add an n pi here. You guys clear with that? Okay, good. But if you have what? Angles that are supplemental, here, there's not an undo. If you have angles that are what? Pi over 2, and this angle 3 pi over 2, they're supplemental. They're opposite of one another, difference by 180 degrees. So that's why we can do the n pi. So I want to point out this detail. So this example is a really good, powerful example as well, and goes into a lot of details. The reason I bring this up is because let's ask you this kind of question here. What number are we up to? Is that 7, 5, or what? 7. Let's do 9 here. So if they give you tangent theta, let's just say is the square root of 3. Okay, what is theta? Well, remember to look at it this way. This is square root of 3 over what? 1. You okay with that? All right. So what's the definition here of tangent? This is what? Opposite over adjacent. Is that true? Okay. Good. It's good to know. Now tangent is what again? Tangent's positive. Is that true? So all students take calculus, quadrant 1, quadrant 2, quadrant 3, quadrant 4. Where is tangent positive? Quadrant 1 and quadrant what? 3. You okay with that? Okay. Now, we're really looking for the reference angle. Here's my reference angle. Definition of tangent, we say is going to be what? Opposite over what? Adjacent. Is that true? Then what's the hypotenuse in this case? 2. Good. What angle are they talking about? Do you guys recognize this as a special triangle? Isn't this 2 and isn't this 1? What is my angle theta? What is my reference angle? Pi over 3. Good. That's a 60-degree angle. Good. This is my reference. So what that means is this angle is what? 60 degrees. Pi over 3. That also means what? This opposite, this reference is what? Pi over 3. You with me on this? So our first solution is pi over 3. Okay, this is my angle. Who can tell me what is the second solution? This is a quadrant 3 angle. How do you find a quadrant 3 angle? They need this angle here. How do we get that angle? What do? You take pi and you do what? Plus the reference. Right? Pi over 3? So let's do the arithmetic. 3 pi over 3 plus pi over 3, what does this give us? So my second particular solution is 4 pi over 3. So these are the solutions that are in the interval from 0 to what? 2 pi. So we'll use this version of the restricted domain. Okay, so this is going to be a 4 pi over 3 angle. Let me erase some of this. Okay, you guys okay with that? Okay, now let's see if you learned anything from the last idea. Let's see if you guys learned anything. What about the general solution? Okay, what about let's say theta is pi over 3. Pi over 3 plus what? Why n pi? Why is this like what we just looked at? Why n pi? Here is my first solution, pi over 3. Is that right? My second solution is in quadrant 3. They are opposite of one another in some sense. So these two solutions differ by a multiple of what? Pi. You guys good with that? A multiple of pi. They're opposite. So what you'll do then is don't add 2n pi. You simply add what? N pi. Because I can get these angles all day long. Get the first angle, pi over 3. Add or subtract another pi. You get what? You get this second solution. They're all coterminal. So you're going back and forth between these opposites like we just described. This is not like the other examples we just did earlier here. Let's go back. I saved them. This is not this situation. You don't have these angles differ by 180 or pi. They're not opposite. So in this case, you add the 2n pi like we did. See this here? We're adding, I'll change this, we're adding 2n pi to both. We have to. We can't be more efficient. But when they're opposite, we can be efficient, and we're just going to keep adding this what? This n pi business. So here's my general solution. Now, let's look at the what? Let's look at the sequence. You guys want to consider the sequence? What do I mean by that? Let's do some algebra. You may see pi over 3 plus multiply the top and bottom by 3 so we can add our fractions. So it would be pi plus 3n pi, everything over 3. Factor out our what? Pi. We get 1 plus 3n over 3. And algebraically, you get pi over 3 times 1 plus 3n. Some books will write it this way. They'll say 3n plus 1 pi over 3. And here's a way for us to generate a sequence of solutions. This is the sequence when we need to, given the general solution. So here's some examples that we just did. Okay. Anybody have any questions on this one here that we just did? No? You sure? Well, it looks like this is all we have time for today. You want to do one more? You want to try to stop here? Anybody have any questions? Okay. So we're going to continue with what we were doing yesterday. Continue with these definitions. So this problem number 11, we got tangent theta being -1. So remember, this is all without using any algebra. This is by definition. Now what you want to go and remember is where is tangent negative, right? So let's look at our quadrants again. 1, 2, 3, and 4. So we know all students take calculus. So what quadrant is tangent, or quadrants is tangent actually negative? All right, we're going to say quadrant 2, quadrant what? 4. Is that right? Let's double check. No, that's not I did 3. Yeah, you're right. Quadrants 2, quadrants 4. Okay, let's double check. Yeah, that looks good. All right, so remember, we're going to have a quadrant 2 angle and a quadrant 3 angle. So let me draw this a little straighter. Not so easy to do. There we go. So we're going to have to look for a reference angle. So we need our reference angle here, right, and a reference angle over here. Now remember the following here. I'm going to put it in red. In terms of your reference angle, maybe theta with that line on top, right? This is always a quadrant 1 angle. So in other words, we want to consider the ratio here of tangent theta being -1. Now, I say ratio because that's how tangent's defined, right? We have opposite over what? Adjacent. Now, this is the reference angle, okay? So we're going to draw a right triangle. I'm going to try not to do it so fast. My reference angle. Remember, opposite here in, oops, sorry, I made a mistake. I got to wake up. What am I talking about here? Let's highlight this. If you're going to talk about a quadrant 1 angle, your reference angle has to be what? Positive. So this is why, I'll go back and erase this. Quadrant 1, all angles, or I should say all of your trig ratios are positive. So your reference angle here, we're going to have to look at tangent theta being equal to +1, not -1. Because it's a quadrant 1 angle here. We're going to look for that reference angle, okay? And that's positive. So I want to point out this detail. So you always find the positive value because it's a quadrant 1 angle for your reference. And so, okay, let's look at the details again, and let's try this again. My opposite side is going to be positive. My adjacent side is going to be what? Positive as well. They're both 1. So what triangle do you guys recognize here when you have 1, 1? Isn't this hypotenuse the square root of 2? So what's the reference angle going to be? So I got a pi over 4 reference angle. So to let you know, we just found the quadrant 1 angle. This is pi over 4. But that's for tangent being +1. Okay? Now that angle, I'm going to erase this here. Pi over 4. Similar here. My reference is pi over 4. And I'm now able to deduce my angles. So the first angle here will be a quadrant 2 angle. So theta 1 is what value? How do we find theta 1? It's quadrant 2. Anybody remember? It's going to be what? Pi, good, minus the reference. Maybe I should put that in red. Pi minus the reference, okay? Pi over 4. What's the second angle going to be? I should say theta 2 now. What will that be? Well, it's a quadrant 4 angle, is that right? So what's that going to be? 2 pi minus, good, the what? The reference angle of pi over 4. Okay, you guys okay with that? Now, you're going to do some algebra. Here's the algebra, right? For pi over 4. We're going to multiply both top and bottom here by 4 minus that pi over 4 reference. And maybe I should have put the second angle over here, and I will. 2 pi minus the pi over 4 reference. Okay, so we have some space to work. And then finally now, let's finish this. Let's do the algebra. So theta 1 here is going to be what? 3 pi over 4. And then theta 2 is going to be what? Oh, we're going to have to say 4 times 2 pi over 4, right? Minus pi over what? 4. Now, in case people don't know, I want to remind people that you want to have, if this denominator is 4, the only way you can actually subtract or add whole numbers with fractions is if they have the same denominator. So here's a 4. Oops, go back. Here's my 4 here. I got to have a 4 there. Now, don't forget to multiply the top by the same value. So this is kind of what's happening visually if you want to think about it that way. It's a shortcut for doing this arithmetic. So now I know that this theta 2 angle should be really equal to 8 pi over 4 minus pi over 4. So what's theta 2 going to be?
7 pi over 4.
It's 7 pi over 4. Good. Here's my angle. Here's my first angle. Now, these are solutions in the interval from what? 0 to what? 2 pi. Okay, so let's find out where this is. Oh, we're going to say this angle here is 3 pi over 4. And then this angle over here is the what? 7 pi over 4 angle. Okay? Now let's erase some of this other stuff that's not really needed. Here, here, here. Okay, and then we just found the second angle. Oops. I wish I had an undo. Undo the erase.
I think you do. It's on there. It's up on the
Right here?
No, the little kind of like spinning arrow.
So oh, show me later. Where is it?
Right above 10.
Oh, right here? This one here?
Yeah.
Oh, is that the undo?
I think so.
Oh, thank you guys. You know, I mean, I used to be, well, I don't want to go down that road, but I used to be a lot more what? Tech savvy, you know. Now I hate technology. It's weird. The older you get, you know, all these changes all the time, you know. Anyway, sorry. I digress. So I have these angles. Let me try to get them back because we got to talk about this. But thank you for showing me that, you know. Okay, we just found, again, the second angle here. There you go. Okay? 7 pi over 4 is a second angle. 3 pi over 4 is the first angle. We saw this tangent being -1. And now what I want to say to you guys is when we talk about the general solution, I want you to notice something interesting here. Okay, these ideas. You could say, if we go to the general solution, you could say the following, that theta 1 is 3 pi over 4, and I want to get every coterminal angle to this, what is it, this first solution. So, okay, let's change this. Here's my angle. Remember that? 3 pi over 4. If I want every solution coterminal to that, you always add a multiple of what? 2n pi. Is that true? And then again, n is an integer. Okay. And you might say, can I write this down this way? Well, yeah, you can. I guess that's actually true. The second solution was 7 pi over 4. And again, here, what you're going to do is you're going to add a multiple of 2n pi. And again, n is a what? Integer. And so you just did the following. You just notated that, well, I'm going to take the second angle here, the solution, and every one that's coterminal to that, you add a multiple of 2n pi. Rotate clockwise or counterclockwise, we obtain these coterminal solutions. Okay, you okay with that? So what I want to remark about this is this. We could do a lot better, meaning even though this here, is something we could describe every solution by, we could be a little more efficient. Here's what I mean by that. So let's just notate this. So I'm going to notate this and say to you, we can actually be more efficient in describing our solutions. We can simply say theta is take the first solution. First solution is theta is 3 pi over 4. Is that right? Good. So take that 3 pi over 4. And I'm going to now remind you guys, we're going to add something different. What do you think we're going to add? Thank you. How do you know we're going to add n pi? In other words, you are right. You guys are right about that. Let me emphasize this idea for the general solution. How do we know we just add an n pi? Yeah, go back over here. Once we had this first solution here, okay? Once you had this 3 pi over 4 solution. God, it's starting to look strange. Once you had that, how do you get the quadrant 4 solution? How do we get this second solution out here being 7 pi over 4? Don't we notice that what's the difference between these angles? Aren't they supplemental? Aren't they opposite in some sense, meaning they differ by 180 or by pi? So what I can do now is this. I can say, let's find this angle, 3 pi over 4. We get the second solution by adding pi. Here it is. We get another solution again by, this also is what? 180. Here's our additional solution, and it doesn't matter if we rotate clockwise or counterclockwise. What we're doing, or what we're noticing here, is simply that these solutions, let me get rid of this. These solutions here are supplemental. They're opposite one another in some ways. So that's why we just add the n pi here, and this is why we can say what we're saying. Let's make sure, though, n is a what? N is an integer, and we can now, describe our solutions. Okay. Now you can also draw the sequence sort of version if you like, by doing some more algebra. Okay. Do you guys know what I'm talking about there? Do you want to look at the sequence version? You want to try that a little bit more? Okay. I'm going to just notate the sequence. Maybe today we won't do that for every one, but it's also good probably for us to practice. Remember, the key, our foundation, is to solve these by the definition. So if I do some algebra here and I say I'm going to actually add that n pi, I have to say 4n pi divided by what? 4. It's that same kind of trick we did in order for us to add a whole number with a fraction. Okay, you looked at this denominator 4, and then that told you what you had to really do. And we could now have 3 pi plus 4n pi, everything over 4. What do we do now? Do you guys know? Factor out what? Pi. And it's really pi over 4. And so we get 3 plus 4n, or you can say this general sequence solution, some books write it as 4n plus 3 with pi over 4. Either way is fine. So this is how we generate the sequence of solution, or I should say, the sequence. It's an algebraic formula. Okay, good. Now, what I really wanted to ask you guys, if you don't mind, anybody have any questions on what we just did? What do you guys think? Are you pretty good now with this? What I really wanted to ask you guys, I started to ask you and to say, I said, okay, what about cotangent being -1, right? What if you had, by the way? I'm sorry, let's go back. Yes?
Actually, so there are two solutions to this, or there are multiple ones, essentially, right?
Well, it depends. If your domain is restricted, and in your homework they're going to say find solutions within this restriction. If that's the case, bless you, these are your solutions right here.
Right, those two.
These two. Okay? But at the same time, they can ask you in the future, give me the general solution. That means all coterminal solutions. So, okay, if they ask for the general solution, then you start with the two particular solutions that we have here, right? And then we add the 2n pi, 2n pi. However, we may notice that we can be a lot more efficient in our description since these solutions, these angles, are all supplemental. They differ by 180. So we can add or subtract we could take one of them and start adding and subtracting the multiple of n pi since they're supplemental, and that's the idea. Remember, what does supplemental mean? Right? They differ by what? 180 really. Okay, or pi. And that's the idea. So here's your general solution now, no restriction, and over here, here's the sequence solution. All right. Now, what I want to remark is, this will be 13. I wanted to talk about this idea here, right? So if they gave us cotangent theta was -1, if that's what they wanted us to do, then how do we actually answer this question here? Okay, what I would suggest is remember what is cotangent, right? Isn't this the reciprocal of tangent? So they're really saying tangent theta is -1. And then what does that actually mean? It means tangent theta is what? -1. We have to solve this for what? Theta. Now, you don't have to. You could have said, can I use the definition of cotangent adjacent over hypotenuse and find a reference as well? And I would say yes, you could have actually done that. You could do it the same way. But, for myself personally, I'll just convert this to a nice tangent equation. And then I'll say, see last example. Yeah, good. Because you solved that one. Okay, you guys okay with that? So, knowing how to do the tangent helps you how to find cotangent. So that's kind of what I wanted to point out to you as a note. So if you wanted to call that 13, I guess you could, or just call it a note, doesn't matter. You guys okay with this idea before we move on? Right, okay. Now, let me kind of emphasize this approach. Because what if they gave us, and like I said, I left all my notes there in my office with all my nice questions. And what if they gave you, for example, how about, what do I have here? How about this? Secant theta, bless you, is +2. Very similar. What do we replace secant with? 1 over cosine theta. And that'll be 1 over cosine theta is +2. And anybody know how to solve this? What does this mean? If 1 over cosine theta is 2 over 1, then what is cosine theta? How do I solve for cosine? Oh, you guys already know? That's good. Cosine theta is what? 1/2. Okay, I'm glad you guys know that. There's different ways you could deduce this, right? You got a proportion, cross multiply, solve for cosine, or just really flip both of those fractions at the same time. So 1 over cosine is cosine, and then 2 over 1 is 1/2. In other words, we got a cosine equation that we solve now for what? Theta. So check your notes. Did we solve this already, cosine theta for 1/2? Did we do this one? Maybe the first day or the second day at any time? Nope. All right, well, that's good. We could do it now. Quadrant 1, quadrant 2, quadrant 3, quadrant what? 4. Okay? All students take calculus. Now, this happens to be positive. So we already know, okay, 1/2 is positive. What does that tell you? Where are your solutions? Where's cosine positive? 1 and 4. Good. So I'm going to look for an angle in quadrant 1, and I'm going to look for an angle in quadrant 4. Of course, we always need the reference angle. Your reference angle is a quadrant 1 angle. In other words, we're going to have to find where cosine, this is my reference angle, is 1/2. Now remember, in quadrant 1, the angle is the what? Reference angle. Or the reference angle is the angle. So let's remember our definition here. So I can call it theta if you really want to call it that. I can erase this. Just want to just remind you guys. And let's draw our what? Our right triangle. Let's draw it slowly here. There you go. What's the definition of cosine? Adjacent over. Good. So 1, 2. What's the opposite side? Square root of 3. All right. Anybody recognize the angle? Is it pi over 6? So we're going to say our reference angle is pi over what? 6? Or pi over 3? What is it? Remember, this is my reference. Well, I don't know. I'm going to tell you what I do. I go, okay, this is actually, oh, it looks like this is a what? Oh, this is 1. This is 2. Oh, okay, that's a what? 60, 60, 60. Pi over 3. Is that true? Okay, so you guys take a look. This is pi over what? 3. Let's do that again. Okay, 60, 60, 60. Yeah, 180 divided by 3 is 60. Okay, so what we found was the reference angle. That means this angle's pi over 3. And then that means that this angle's what? Pi over 3. Good. So let's look at the particular solutions. What's my quadrant 1 solution? Well, we already had that. Pi over 3. What's the quadrant 4 solution? How do I find a quadrant 4 angle knowing the reference? What is it again? 2 pi minus what? The reference of pi over 3. Okay, good. Let's do some algebra then. Okay, so it'll be 3 times 2 pi over 3, right? Minus that pi over 3. So notice again, if my denominator here is what? 3, in order to add or subtract, here's our shortcut, if you want to think of it that way. Adding a whole number with a fraction. So now I get 6 pi over 3 minus pi over 3. And so what's the second solution? It's 5 pi over 3. And what should we say about these particular solutions? These are all solutions that are where? Between 0 and what? 2 pi. Okay, they're solutions in this picture. So let me go back and erase the reference. Let's label pi over 3. What's the other one? Was it 5 pi over 3? Okay, first solution, pi over 3. Second is 5 pi over 3. And that's in our restricted domain here between 0 and what? 2 pi. Yes?
So the answer could be 0 but not 2 pi.
Yeah, if you're looking at this interval here, they're excluding the possibility of 2 pi. You're correct. So because it's coterminal, meaning 0 and 2 pi. So we only need one of them. So it's a very strict idea. You're actually looking just at this particular interval. So there we go. Now let's talk about what? What comes next? Since you guys want to talk about those two, what is it? How does a general solution look? What do? We say, okay, theta 1 we know is pi over 3. Theta 2 we know is 5 pi over 3. And you might say, let's just then keep it simple and add your what? 2n pi's, because you're finding, again, let's go back. Here's our first angle. Is that true? Here's our first solution. And in order to get every other coterminal solution here, we add a multiple of 2n pi. Is that right? All right. Now, that's describing this first general solution. Describing the second general solution, you take the second particular solution and you added the multiple of what? 2n pi again. So this is how you got your general solution. But now I'm going to check to see if you guys are awake. Let's see if you understand this idea that we talked about, right? Let's see if you understand this. Can I do a little better? Can I be more efficient with describing the general solution, meaning every solution that satisfies this equation?
No.
Can I be more efficient? Yes or no? The answer is no. Good. Why is this why do you guys say no? Anybody know why? Let's try to find a. Why is it no? Why are you done here with the general solution description? You say, I can move on. This is my answer. Looking back at the book, you guys see this. Why is that?
And the same terminal.
Well, let's see. Let's start with the first. Let's start with the first what? Solution, pi over 3. Okay, you okay with that? Here's my first solution. Is that angle have another solution that's supplemental? In other words, in quadrant 3. Do you see this kind of picture here? Say what? No. So in other words, if you don't have this opposite quadrant solution scenario where the angles differ by 180 or pi, then you are done with your what? General solution description. You okay with that? What do you guys think? Is that okay? Okay, you guys clear with this?
Is that the final answer? Or just the solution?
Well, if they ask you for the general solution, you guys tell me, is this your final answer? Yes, good. So if they ask for the general solution, this is your answer. If they ask for a particular solutions here for a restricted domain, then yes, you're going to have these two. But this is your general solution. This is what I'm getting at. Okay? So I want to emphasize this idea. You don't have solutions that are what? In opposite quadrants this way. So you don't have that scenario. So since you don't have it, you can't be more efficient in your description. You are done. You're looking back at the book, this is what you'll see. So if you wanted to describe now, let's describe now the what? You want to do the algebra and describe the sequences, since we're on the topic? Okay. First solution, let's do some algebra. Pi over 3 plus 3 times 2n pi over what? 3. Let's go over this. Here's a 3. We need these to add our whole numbers with our fractions. So we get pi over 3 plus our 6n pi over 3. Okay? What do we factor out? Pi over 3, 1 plus 6n, or we can say that first is 6n plus 1 times the multiple of pi over 3. This will generate our sequence. The second solution we found was 5 pi over 3, right, plus 2n pi. And don't forget, with our 2n pi, we have to multiply by what? 3, right? Same idea. This 3 are these 3 are here. So we get 5 pi over 3 plus 6n pi over 3. And then theta 2 now will be, if we factor, well, we're going to add the 2. 5 pi plus 6n pi over 3, or factor. Theta 2 becomes pi over 3 times 5 plus what? 6n. Or theta 2 would be 6n plus 5 times pi over 3. Okay? We didn't do this step here. well, I'm sorry, let's go back here. Let's erase this. Looks like we didn't do this first step here. We didn't actually, but it doesn't matter. So here's our sequence version, okay, of our general solution. We could generate we could generate the sequence here with these. So this is kind of where we're at. Okay, what do you guys think? Is that okay? Anybody have any questions on these here? Okay, you sure? No questions? So this problem here, where we said secant theta is 2, we actually converted this to a cosine equation or definition, and you get cosine theta is 1/2. All right, how many of you guys are bored with all these examples here? Anybody bored? You go, okay, we've seen enough? Huh? You guys seen enough?